Hi folks, welcome back to Math with Captain Rod. I make this video here to go through some examples of solving quadratic equations, some or maybe all of which have complex solutions. So we're going to take a look at the three examples I've got written out. Let's start with this one. Now there's lots of methods we can use to solve this. We could apply the quadratic formula and completing the square and whatnot. And I'm just going to solve this kind of directly here. We'll start by subtracting 64 from both sides. This one can be solved just by taking the square root of both sides. Now at this point right here, early on in algebra, one of the first things that people are taught is, well, this thing has no solution. Well, it turns out it has no real solution. It does have what's called an imaginary solution. So when we square root both sides, we get x equals the square root of negative 64, which is the square root of negative 1 times 64. Square root of 64 is 8, and the square root of negative 1 is I. Remember that I is the imaginary number, such that I squared is equal to negative 1. So we would normally say this doesn't have a real solution, and it doesn't, but it does have an imaginary solution, 8i. Oh, pardon me. Okay, so, and really it's plus or minus. Plus or minus 8i, both of which will solve that. Forgot about that. Don't forget, any solution in the form x squared equals is going to have two solutions to it, a plus and a minus. All right, let's take a look at this one. So this one can't be solved quite the same way. So I think what I'll do is apply the quadratic formula to that. So x is going to be the opposite of b, plus or minus the square root of, b squared would be 16 minus 4 times 1 times 13, all over twice a. That's going to be just 2. All right, so we're going to have negative 4 plus or minus. Now let's inspect under this radical here. So what do we get here? This is 52. So we got 16 minus 52, and that is going to be negative, give me a moment here. Again, I haven't had my coffee this morning. Minus 36. Sorry about that. Again, I'm going on 1 cup, and I normally have 2. All right, so taking a look at this here, we get negative 4 plus or minus. Now, the square root of 36 is 6, and square root of negative 1 is I. So 6i over 2. And this is okay. We could separate it out a little bit. Let's do this. I mean, they're obviously both divisible by 2, so how about negative 2 plus or minus 3i? And again, that's the complex number here. There's 2 of them, negative 2 plus 3i and negative 2 minus 3i. Those are the 2 solutions to this equation. And again, it has no real solution, but it does have a pair of complex solutions. All right, let's take a look at this one. I suspect the same thing will happen. First step is to add 17 to both sides. Then we apply the quadratic formula. So let's see, x is going to be opposite of b, plus or minus the square root of, b squared is 64, and then minus 4 times 1 times 17, all over twice a. So what do we got out of that here? We're going to have negative 8 plus or minus the square root of, oh boy, what's going on in here? So we got 17 times 4, that's 28 to 68. 64 minus 68 is negative 4, all over 2. And the square root of negative 4 is 2i. Because the square root of 4 is the 2, and the square root of minus 1 is I. Both of these are divisible by 2, so we get negative 4 plus or minus 1i. And those are the 2 solutions. Negative 4 plus I solves this equation. Negative 4 minus I solves it. And you can try that if you wish. If you take negative 4 plus I, sub it here, and FOIL it, and then plus 8 times this, out will come negative 17 if this has all worked, right? So the purpose of this video is to help demonstrate how to solve quadratic equations that have complex solutions. I hope that this has helped out with that. Have a great day.